Welcome to the second lab of Introductory Physics. In this lab we will show the free fall of an object. The fall of an object is related to Newton's second law of motion. Let's see what Newton's second law means. The second law shows that the change in velocity is proportional to the net force and the change in time inversely proportional to the mass of an object. And the change in position is proportional to the change in velocity times the change in time. As mentioned before, we measure the change in position of a free-falling object. The object follows the law of gravity. Weight is defined as the mass of the object times the gravity and goes in the negative y direction. For this lab, I choose the most known example. Isaac Newton, one of the greatest minds of all time, told that he was sitting under an apple tree and saw an apple falling down. That was the basis of the law of gravity. We will repeat this experiment. To have a better resolution, the video is rotated by 90 degrees and the gravity goes in positive x direction instead of negative y direction. It is shown that the velocity is not constant. So we see an apple is following the law of gravity. What was expected? But what would happen if Newton was not born in Britain and he was living somewhere warmer? So he would not sit on an apple tree, but maybe on a lemon tree. Does a lemon follow also the law of gravity? Let's see. As we can see, also lemons follow the law of gravity. So we can assume that every object on Earth with mass is following the law of gravity. We will simulate the apple and the lemon and including an arrow showing the gravity. Now we can compare the experiment data with the simulation and see that the experiment data and the simulation for the apple fit very well. It is difficult to find an exact position of the falling object because the object is blurry due to high velocities. If we compare the experiment data and the simulation of the lemon, we see that both curves fit also well. But at the end, the curves are not exactly the same. We have to introduce drag forces. Drag forces are equal to a constant b times the velocity, and they go into the opposite direction of the velocity. If we assume b is equal to 0.05 and adding the drag force to the net force, we will see that the experiment data fit very well with the simulation. That was the second lab of Introductory Physics. Thank you for watching this video.